Awesome.
All right.
So welcome back to the Ceph Developer Monthly. This is the edition of June 2018. And as the usual, we have lots of interesting topics to discuss. So today we have Kefu talking about C-Star, Jeff Layton talking about NFS Ganesha and CephFS in clustering mode, and Sage with a bunch of interesting topics. So please go ahead, Kefu. Showtime, man.
Thanks, Leo. I'd like to talk about the items we need to work on in the future. I'm putting the pad link in the chat. I'm putting a lot of details in the pad. And currently we have a system messenger and a simple ping pong unit test, and also a alien engine. It's still a work in progress. Can you guys hear me? Okay. Cool. And I will be also post the C-Star branch in chat. Hold on. Start. In the chat.
Yep.
So
it's not just humans. Sorry.
Okay, I'm sorry. So the missing thing is that one thing we need to think about is that we're going to have a multiple OSD instances co-located in the same process. And does this imply that we will have a single authorizer and a single mode client in this process? And
my assumption is that they would operate just completely independently like they do now. They'd have their own mon clients and everything, except that they would be in the same process. That would be the first step. But I haven't actually thought through how the messengers are going to get combined. I think that might be so refreshing my memory. The reason why we need to do this is because they're going to share the same DPDK network card, right? That's the reason why we want to put multiple OSDs.
I guess so.
Yeah, that's the long-term reason. Like the short-term one, I guess, is just to make it simpler to allocate cores among them and schedule, just include the scheduling without having to kind of manage the whole box, multiple processes.
And we should be able to do that without having any sharing of the messengers or anything really.
Right, so
you don't actually need to share anything.
Could not share anything to start with, and then optimize it later.
Yeah. Okay, that sounds good. I think a lot of the work has been done to strip out the Ceph context usage in OSD. It's probably crept in some places, but it's largely separated out. So I actually don't think that's going to be that big of a thing to do.
So the answer is that we will let the multiple OSD instances share the same client and other infrastructure as much as possible.
I don't think they need to. I would leave them separate for now because they'd have to think through what the implications of sharing the same one are. Yeah, maybe eventually. Yeah.
I don't see any drawback from the share everything model.
Yeah.
I guess the drawback is that we do need more coordination across cores to make it work.
Yeah, because
the channel layer should be.
Yep, I think the assumption was that the initially, at least, certainly, and probably indefinitely, we would leave things like mon client in the alien framework, and so they're already going to be. None of them are hot paths, So they'll already be doing inefficient message passing between cores. Otherwise, we have to re-implement on client. Which sounds
which probably we will separate one client for each OS instance.
Yeah.
And,
I think I would. Yeah. This seems like this is an orthogonal concern. Like we can proceed with everything else just with a single OSD in the process, and at some point we'll do this work to have multiple OSDs and figure out what the right way to do it. But I'm not sure that there are any dependencies between it and the rest of the C-star stuff, or the other way around. Is that right?
No, I agree. I just thought it would be easier in the C-star world and more intuitive. But yeah, we can leave it for future.
Okay.
And also regarding the config, because we should allow the user to change the config on the fly, and each core should have its own copy of a OS config. So I'm not sure this bullet item makes sense. For example, the only OSD subsets are included, and each core has its own copy of OSD. And we will eliminate the global Ceph context just as Steve mentioned, and also GConf. Probably we can temporize or conditional compile the config.cc so we can remove all the locks in the code path, because we don't want any lock in the code path in C star, right?
It kind of seems like the thing that we want is something more like RCU.
Yeah, that's exactly what this big single line too. We have a read-only copy that we don't care about changing, and
the same thing.
It updates. It's a very small thing to just point to a new copy of it.
I'm going to message you a link afterwards.
I mean, so one of the first things that that I was thinking of as terms of sharing stuff across cores was the OSD cache, all the OSD maps, and the model I had in my head was like an RCU where you would have a hash table or the lookup table or whatever pointing at mapping epochs to pointers to the OSD maps. The OSD maps themselves would be entirely constant. And then when you ever refreshed, you'd just generate a new hash table and they would do an RCU type thing where you flip the pointer to the latest hash table. So that way everyone can do unprotected reads and lookups of OSDs.
But doesn't the RCU apply to the config?
So we could probably do something similar with the config, I guess, is what I was suggesting.
Okay, I take a look at it. RCU. Do you have a pad on the RCU related thing?
No, and I'm not sure if we need like actual RCU. Like we could do like a poor man's RCU, or re-implement something similar.
Okay.
But yeah,
there is a pretty nice userland RCU library, libu RCU. I don't know how easy it would be to plug into C++, but I've used it in C before.
I think even we tried playing around with it at one point on something, but yeah, okay.
Okay, and regarding logging, I just found Muhammad is actively working on it. I just wanted to update you guys with the progress, and I checked his work. What he's doing is to add for adding a new log entry, we need to add a trace point in a file on the trace tool, and then add a call in source file. It's exactly what we are doing to add a trace point. But it has its downside, because one thing that we're trying to reduce the stream to reduce the overhead when creating log, but in in the approach, we print whenever we print a new variable, non-trivial variable, we use a new instance for signify the variable. That's a lot of overhead. Probably we should consider this when it's becoming hotspot.
Yeah, so this seems like the first step is just like Mohammed's done so far is converting everything to trace points, but not making them efficient trace points. I think the second step is probably going through each individual log line and either removing the non-constant pieces so that we can make them trace points that just have a fixed size data being output of a constant type, or changing those log lines entirely.
Actually, I have an update if I can.
Oh, sure, that'd be great.
I was actually planning on opening a PR today, but I'm preparing my Ceph talk at a local meetup, so that's why I haven't had time to send it yet. But basically, it's ready. It's working good. I replaced it in BlueStore. I've converted the outs to LTTNG trace points, and I've used FIO with the object store backend to benchmark it. I've seen about like a 10% throughput enhancement, where compared to D out with a log level of 10. And for the disk size, it goes from like 100 megabytes to 40 megabytes for the run that I had basically. It's like a 60% improvement. Yeah, and I'm actually using the approach that is used in QEMU for deciding which backend to use. I don't know if you guys are familiar with it, but basically it's like a script, and you tell it which backend you want, and then it will generate C code that implements the backend. And a few years ago, I added LTTNG support for it. So I basically just took that code and ported it to Ceph right now. And actually, I'll just open a PR after this call, and I'll update the mailing list with it. But I guess I'm curious how, or maybe you should raise this on Ceph-Devel, but how do we get this moving? What you want to see next?
Yeah, I think sending it to Ceph-Devel sounds like the next step. I have one quick question before we get totally sidetracked on this. This is basically taking the existing DOUTs and channeling them through basically effectively an arbitrary string through a single, basically through LTTNG, right? Like it's still just a unstructured log.
Not really, actually. Not really, because what I had done for Ceph-Lecon, it looked like the overhead was really coming from copying strings.
Yeah.
Whether you're using the out or LTTNG, that was really the bottleneck. So what I did actually was you go in the code and you have to convert all the outs to a function which is trace underscore your trace point name. And you give it the payload as a parameter to the function. And then the code that is generated by the trace tool script will implement that trace underscore trace point. It'll be the out, or it'll be trace point, LTTNG API, or it can be something else. But basically on the cal side, it becomes trace underscore TP name.
And you did that for all of BlueStore?
I did that manually for BlueStore.cc. It took a while just to go through that.
I'm impressed. Okay. Okay. So I guess what I was gonna say was, it seems like if for these trace points, like we should basically not use string stream ever. Like if we have to stringify something, then probably it means that our trace point is like not a well-structured trace point, or is not logging the right thing.
Actually, because the out used to take objects,
yeah.
And yeah, so I added the operator string for most of them.
Right.
You have to go through that, or you have to find another way to convert them to basic types to have them in the payload. Yeah.
So it seems like. Sorry.
Probably you can piecemeal this to convert them to the most structured way.
Yeah. Yep. And if there's a way to like have a trace point that's annotated such that you know it's like a verbose slow debug type trace point, then you can still have something that works kind of like dout, where you just like spam the log with a huge structure because you're trying to figure out what the hell's going on in your developer. As long as that compiles away sanely, then, or not, it doesn't compile away, but at runtime it never actually gets called.
Yeah, I think the Kip had pointed out on self-devel that, or I don't know where, but basically the DL line is executed even though it's not printed. I don't think that's the case for LTTNG, and there are also log levels.
Okay.
But yeah, anyway.
Cool. Okay.
Okay, let me continue.
Okay.
Next item is object and the log client. I believe the object is in the critical path of OT.
It's only used for cache tiering though, and that's always going to go across the network. So I think we can keep that in alien thread for now.
This is almost exactly like the account one, except that transaction is more difficult.
It's not in the local I/O path at all, so it's going to be slow over the network anyway.
Okay, so we can keep it in alien thread. And the log client. And it's all,
Let's see the
only
same thing.
loading.
Yeah, it's only like cluster level logs, or like those barely happen ever. Like they're pretty rare, so I wouldn't worry about that either.
Okay. And next is alien engine. It's a mimic of an engine in C# world. It's a reactor for non-C# tasks, so we can schedule non-C# tasks from C# thread. It has some building blocks like condition variable and thread pool, etc. So we can submit function to alien engine. Or we can just use it so we can export the object and log client as a service for C# threads. It will be used to implement the OSMap caching service and authorized service will be mentioned later. The OSMap caching service will be consumed by the and updated by C# threads. For example, it will maintain the active the OSMap still being used by all the PG map in the by all the PGs in served by current OSDC instance, and it will offer some methods like get map, put map, and add map, and probably remove map. They will be called by C# thread or the alien thread, as the alien thread could update the mini OSD map also. The mini OSD caching service also. And I think each core will holding a ref count of the number of the OSD map is actively using. And when this decrement to 0, it will return the reference to the core where the caching is running. And then and then is the mini service.
Sorry, one quick
authorizer.
comment on the OSD map caching service for a sec.
Yeah.
So it feels to me like the question is how far how far to go in one extreme, because to do this in the extreme high performance case, then we would want to avoid the ping pong between CPU cores in order to look up OSD maps. And we would also want to avoid OSD map ref, I think, because that's manipulating an atomic that is actually synchronizing cache lines or whatever across cores. So one way to do that would be like an RCU-like thing where the OSD maps, you just end up with like a raw pointer to a constant in-memory OSD map. And then there's some other thing that makes sure that the reference has gone away by the time that you retire, or you free that memory.
By memory, you mean the memory held by C-star or non-C-star?
I mean that you would, when you get a new map, you would allocate it in memory and you would add it to the lookup table or whatever, and somehow make it so that all the cores could see it, using like a atomic update to the hash lookup table or something like that. And then when you want to trim something from the cache, you just have to make sure that there are no cores that are accessing that reference to the OSD map anymore. And so you wait some period where you make sure that all the work on those cores has completed such that they won't be referencing that map. I don't know exactly how that would work, but that's sort of the extreme. I'd assume that we would need to do something closer to that, but I guess the simpler solution is really just to do what you're saying, where you just the get map lookup is not blocking, but feature based, and then use reference counts. That's probably enough.
In particular, you can maintain a ref count to a map on every core, and then just have the central ref count be whether it's used by any cores, and so it only gets updated when a core is done with that map.
Yeah,
they play the same cost as RCU, and it's much simpler.
Yes, yeah, that would simplify the ref counting. Yes. And then the lookup part, you could, if you make it so that the hash table that is the lookup table is also read-only, and you're just publishing new versions of that hash table, you're telling each core that would also work. But I guess
so each core has a history of the lookup table, right?
Yeah.
Okay. Good one.
That simplifies the code a little bit in that you don't have to wrap the lookup in a feature, but it might actually be that we don't look up maps that often, and so it might not matter. Because usually for most IOs, like the only time we're really looking at maps, it's when it's like during peering and PG creation, and so we might be getting ahead of ourselves there too.
Yeah, I think we really just want to notify each core when there's a new map and let it take a ref and then do the cleanup later
Make its
on.
own.
But I don't think we want to maintain a hash map with RCU. That's just very complicated and probably would break our coherency anyway, like our good patterns that C-star gives us.
Yeah, way to
random bus blocking.
Yeah. So maybe this probably warrants its own thread on Ceph Develop to kick around a couple options here and see which one. Because you could just basically pass pass the message each core. Each core could have its own local cache hash table. That'd be one way to do it. But all referencing the same. I don't know, whatever. Yeah. Okay. Okay.
Yeah, we definitely can have a local hash table for each core. And the same idea go to the authorizer service. It just serve it just run the mon client. It's in the agent thread and keep updating the credentials and offer the non-blocking calls for C-star word, like get authorizer and put authorizer. I guess that's all I have. So the next thing to do is to implement the engine.
Yeah.
Using the ASIO thread pool or a plain thread pool using the C++11 thread. But we cannot use the good old thread pool in Ceph because it's using a lock.
Yeah.
And And then the next thing is to implement the OSTEAM application service and the authorized service, and then we can start work. That's the really fun OST stuff, and go to the IO path.
That sounds right. The logging is in there somewhere too, right?
Yeah, I guess Mohammed will be take care of it.
That's great to me.
Yeah, and also the config. I think it could be trivial once we remove the logging.
Yeah, that all sounds good to me too.
Okay.
Cool. Really excited to get back to this. Let's see some progress. Excellent.
Also, I will send some PR to master regarding to the shall we have a branch so we can we can work on in the Ceph or how should we call if we have one more contributor working on this stuff? How should we collaborate?
Yeah, I mean,
coordinate.
I think in an ideal world we could put a bunch of this in master and it'll just be dormant code, unless you're actually. But
yeah, I think in short term, like in 1 month or two, we will have a very messy code base.
Yeah. Yep.
Anyway, I'll send a patch.
Create a branch.
Yeah. Yep.
I was just saying you should create a branch in Ceph.git and people can send PRs against it if they want to collaborate on that. That's what I would do.
Yeah, I think so.
Or in my own repo.
I put it in Ceph.git for visibility, probably.
That and merge early, merge soon, whatever pieces you can.
Yes, exactly. Yes. Yep. Yeah, I mean, I think as we start, I don't know how realistic this is going to be, but my hope would be that as we start to get into the deep work of like rewriting parts of the OSD.io path, we would just have like all of that code sitting in master in the OSD, and it would just, none of those code paths would get taken until you like flip the mode or like make one change or something like that. So that the code is sitting side by side, and then eventually we'll just delete all the old stuff. But instead of having heavily modified code in another branch, just having a parallel implementation, because we'll probably like be renaming functions and re-implementing half the stuff anyway. So
we can start to put the working progress in master, as long as it's not interfere with the code path.
Yeah. If as much as possible, if we can put it in master, that would be better. Yeah.
I'm concerned that if we do that, we're going to have parallel implementations, and that means we'll lose bug fixes, though.
It's no less parallel than if it were in a separate branch, right?
Well, if it's in a separate branch, then we can have a patch that like does the move, also deletes the old code, and then if there's a conflict in that code, we can look like it'll be a lot of conflicts, but we look at it and go, okay, there were no bug fixes here, we've lost when we try and merge it or whatever.
On the other hand, if you keep you change outside, then the merge is gonna be
horrible.
You're gonna miss bugs, bug fixes, and you not anyway, but there's high chances in both ways. So
I think the good news. Yep. I think the good news is that there aren't that many changes actually happening in the IO path in USD these days. Most of the changes are like appearing, which won't be touched for the most part. So hopefully this won't come up too much. But yeah, I think probably we should just start with like what the actual pull requests are, and we can decide if this can go into master, then great. If it like can't, or then we can figure out what else to do. But
cool. Will do.
Yeah.
And since I was helping you with some brand, okay, some reports we need to focus in Ceph, on the Ceph. For example, the C star, the format, acre, some report used by C star. So we can point it to no.
Your audio's cutting out too much. I can't quite follow it.
Oh, I mean, I will ping you with some reports so we can fork them in our Ceph slash.
Okay.
Because
Perfect.
I modified some part of it
For submodules. Yeah.
So we can work together with
Awesome.
ours. Thanks.
Okay. Sounds great.
Okay. I'm done. I'm good.
Cool.
All right. Thanks, Kifu.
Thanks.
Thanks, guys.
All right. Jeff, you want to go?
Sure. Let's see. I'm going to try to share my screen here. Let's see if this works. And I'm going to want share. Okay. Can everybody see this? Hello? Yes? No?
Nope. It's a blank screen with the mouse cursor.
Jeez. Try this again. Yeah, it doesn't seem to like my. Here, I'll try this one. Maybe I can do the window. There. Is that better?
That's better. Yep. Yep. Perfect.
Okay, great. All right. Hang on a second. Let me move this into. Actually, hang on a second. I'll change this. Try a different window. Got it. There. That okay?
Perfect. Yep.
Great. Okay, thanks. So I'll try to keep this pretty brief. This is some work I've been doing for, I've been actually looking at this for several years, but I actually started picking up and doing the actual work on it about 6 months ago. And the idea is to build NFS Ganesha, or to change NFS Ganesha, it doesn't necessarily have to be NFS Ganesha, but it's what I'm using to work in an active-active configuration on top of a clustered file system like CephFS. And so CephFS is the prototype for this. Yeah. So in any case, I'll go real briefly. I'm not going to talk about RADOS or CephFS because you guys know what that is. But this is, so I've built this presentation and with idea of maybe taking it on the conference track. But in any case, Ganesha is a userland NFS server, and that's sort of the place I've been doing this work. So the idea is that it has has plugins in the back end for different types of file systems, and there was already an FSL Ceph that uses libCephFS, and it's but we can also store recovery databases and configs there. So in any case, we've had CephFS or FSL Ceph for a while now, and we are actually shipping it in RHCS 3.0. So it's just a traditional sort of cluster setup using Pacemaker. But the key is that active configurations actually on Ceph work pretty well. You have the CephFS is pretty good at mediating conflicts, and so we have stuff like opens, locks, delegations, layouts, all that kind of stuff is pretty well handled at the file system layer. And so if you just stand up a bunch of independent Ganesha servers on top of CephFS, it mostly kind of just works. The catch here is that it doesn't work. There are problems when when a node crashes. If a Ganesha node crashes or something crashes in Ceph, then we have to do some special handling, and that doesn't exist yet. So Ganesha already had some clustering support too, It's mostly for GPFS, but it's a little hinky. It does some, it uses dbus to sort of drive Ganesh to do certain things. You have to split and merge recovery databases, and the way they do that is not atomic enough, and so you can end up in situations where the recovery databases don't end up being failed over correctly, and so it's not resilient enough, in my opinion. And so I think there's also some race windows where you can end up with conflicting state as well, because the way they handle a lot of it and just let things time out and assume that everything is going to be okay within that period, and that's not necessarily the case. So in any case, this is what I'm looking to build, is sort of a scale-out NFS server over CephFS. What we want to be able to do is stand up these individual NFS Ganesha servers in an active-active configuration. We want to have them mostly run independently and really only get together and coordinate when they have to, which is typically only during recovery, like when the node is coming up and we need to allow NFS clients to reclaim. And the other good thing here is that Ganesh is pretty amenable to containerization in this configuration. There's no real need for local storage. Everything goes into Rados or into CephFS. We don't really need third-party clustering. And so, what I'm looking to do actually is not even bother with trying to do failover in a traditional NFS way, where we had to have another node take over the resources that this other one was using, but rather just stand up a new container whenever one crashes. And I think that's an much easier model to start with. So we may need to do some takeover kind of stuff eventually to handle migration. So like if we want to move a client from one NFS Ganesha server to another in the cluster so that we can, for instance, decommission that NFS Ganesha, we would need to be able to handle that. And that's not implemented yet, but it could be done. So to do this, we have to kind of step back and look at what happens in a single node configuration, right? So after a restart, NFS servers are sort of a blank slate. They don't have any knowledge of what the clients held before. And so what we do is typically we bring up an NFS server in a particular way and to allow the clients to reclaim their state. They say, hey, I had this file open in this way, I had this lock on this file, et cetera, et cetera. And so during that period, we call that period the grace period. And so the grace period, during that time, clients are not allowed to establish any new state. They can only do reclaims. And so to allow that, to handle those reclaims, there are certain scenarios where if you have reboots along with network partition, like a client loses contact with a NFS server, that server reboots a couple times and has forgotten all about that client could come back in on a subsequent reboot and reclaim state that it really shouldn't have. And so what we do, the way we handle that is we have to keep a list on stable storage of which clients are allowed to reclaim. So we do that. Typically, this is done in pretty much all NFS servers that don't track state on a real granular basis on stable storage. So this is sort of the minimum we have to do to allow clients to handle that sort of, or to allow servers to prevent that sort of condition. And so the other catch here is that, and the important bit is that we have to atomically replace the old client database with the new just prior to ending the grace period. So up until the point where we end the grace period, whatever database existed prior to that is authoritative. Once we lift the grace period, that point the new database is the authoritative one. So a way to think about this, and this is sort of a simplification for that'll make sense later, is to consider each reboot a particular epoch. So when a NFS server crashes, we have a period where we have a grace period, and then it comes up, it goes through the grace period, we allow recovery, and then we go to normal operations. And then we have another grace period, and then we do normal operations, and we have another grace period, normal operations. And so if we consider each of those periods an epoch, that allows us some. It's another way to look at this, and it's a little simpler for dealing with a clustered grace period. Oops, sorry. So now we have to think about what happens when we have multiple servers. So in that case, we have to think, really what the whole point of the grace period is to prevent conflicting state from being acquired during reclaim. So and we have to worry about conflicting state being handed out on other servers as well in a clustered setup. So at that point, we really have to consider the grace period to be a cluster-wide property. We need to enforce a grace period until it's no longer needed by any node. And that means that when we think about it, if the node crashes while the grace period's in effect, we want to allow it to rejoin. And then that means that lifting grace is really a two-part process. We have to sort of indicate that this node, the node, I don't really need a grace period anymore. And then we have to indicate when we've stopped enforcing it too, when no one needs it any longer. And so essentially it's a cluster-wide property. You guys feel free to stop and ask questions if I'm not clear on any of this. Kind of breezing through these slides. So in any case, we have one way the simplest way I found to represent all this is I'll keep track of flag per NFS server. So each server in the cluster gets a flag that says whether it needs a grace period. So when it comes up, it crashes, comes back up, and says, hey, I need a grace period. I got to allow my clients to reclaim. And then we also have keep a track of a flag that says whether it's enforcing the grace period. So when the NFS server has finished all of its reclaim, but another node in the cluster is still allowing reclaim to, or still needs a grace period, then we set a flag to indicate whether that it's still enforcing. So we have to separate, where we usually in a single node NFS server, a singleton NFS server, we would conflate these two ideas, but in a cluster we have to consider them separately. And so the idea here is that we really want very simple logic that allows the NFS servers to make decisions about grace period enforcement based on the state of all the servers in the cluster. And we want that to be decentralized. We don't really want a single node figuring this out. So in any case, the way I've done this is I've created I'm using a single object in Rados as a database, and so that database, usually I call it Grace within that server, or within Rados, and essentially it just tracks a very small amount of data. So we have two UNT64T values that represent the epoch. First is the current epoch, which is where new records should be stored and what whatever the current reboot epoch is. And then we have an R value, which is the recovery epoch. And that's during a grace period that will be non-zero, and that will indicate what epoch we are allowing recovery from. So if a server comes in after it's been out of communication for a while, it can look at that R value, and if it doesn't have a database for that R value that's represented there, it won't allow any recovery. And then also in that database, we track an OMAP, which is that just tracks the two flags. And essentially, I just have a byte in there that and I'm using two bits out of that byte right now. So we have space for other flags later if we need. So there's a need grace flag and an enforcing grace flag in there. At the same time, we also have to allow for parallel server recovery databases. So in a clustered setup, each server node in there is going to have a list of its own clients that it has, and it needs to keep track of that list separately from all the others. And so what I do here is, but the key is that when we switch epochs, we need to have an atomic switch on those databases as well. And so that's tricky because we can't do atomic operations across multiple nodes or across multiple OIDs in Rados. You can only do a single, the level of atomicity in Rados is just on a single object. So we have to allow. So what I've done is we just embed the current epoch value in the name of the database in Rados. So and they look like this. There's a rec dash, and then there's the epoch string with an epoch value in it, and then I have the host name after that, which we may actually change that to be something different besides the host name in a future version. But for now, it's what it uses. So it's just an opaque node ID effectively. And we use the traditional. Ganesh has had the ability to store recovery databases for singleton servers for a long time, and we use the same format for that database in these recovery databases. And when an epoch changes, we can also go through and clear out any of the ones that we know will never be used for recovery anymore. Once we're well beyond the point where we would recover from that database, we can just delete it.
So just a quick question: when a server is going from grace to normal operation, it first clears its needs grace, but still enforcing grace, and at that point, it would presumably write out the new version for the next epoch of its client database. Is that right? And then once when we transition, so what happens is during recovery, what we do is we have you may have an old database that says, okay, I'm allowing these clients to recover, right? But and as those clients come in to recover, we add new records for them in the current epoch database. Okay.
So,
that makes sense.
And then what we do is just delete the old one. Yeah, I'll make sure I update that on the slide because you're right, that's not clear.
The new record database would always exist unless basically the server failed to participate in the grace, in which case it get fenced or something, right? Something weird.
Right. Effectively, it could still come back in, but if it doesn't have a database for the current recovery epoch, it would not allow anything to recover. It would have basically no database for it, and so no clients would be able to recover, which is exactly what we want. We don't want those clients coming back in.
Sounds good.
All right. Good. So in any case, I have, as part of that, so that, we have a recovery backend that implements this for Ganesha now, and it just got merged this past week. And then there's a command line tool that goes along with it that allows you to basically manipulate this database at will, or an administrator can come in and do that, and also allows you to do things like add nodes to the cluster. For instance, if we want to grow out and scale out a little bit, or we'd be able to remove nodes too. Right now, I don't have a way to migrate clients that off of an existing node automatically, but that could be added. But in order to shrink the cluster, we'd have to basically delete its OMAP key, and effectively that's what this tool allows us to do. So it allows us to add, remove stuff from the cluster, add, remove nodes from the cluster, start a new grace period or join an existing one, lift the grace period for one or more nodes, or set or clear the enforcing flags. So in any case, the way we have to think about this now is that each clustered NFS server has its own life cycle, and so this is a way to think about the states as we walk through them. So the first one is the startup state. So first we start up from 0 for the server, and so essentially this node will either request a new grace period or join one that's already if there's one already active. So effectively we just ensure that both the need and enforcing flags are set, and then we wait for all the other nodes in the cluster to set their enforcing flags. The reason we do that is that we need to ensure that we don't kill off state held on the Ceph MDS by a previous cluster node or previous instance of that cluster node. So if a node crashes and comes back, I'll talk about that here in a bit, but if it crashes and comes back, we want the MDS to preserve its state, at least for a little while, until we are ready to start reclaim. And so we're actually adding some stuff to CephFS, to libCephFS for that. JUN has some patches for it, and I've been testing them. They work pretty well. So in any case, assuming once the server comes, once all the other servers are enforcing, we load up the exports table at that point, and then we kill off any state that was held by this particular NFS server before. And then, because at that point we are safe to do so, we know no conflicting state can be acquired, and the MDS is clear to release that state at that point, so that we can allow clients to reclaim it. So at that point, we transition to the recovery state. So we start a grace period timer. So we don't want to wait forever for these clients to reclaim. We just give them a certain amount of time, and usually it's half a minute or a minute and a half, or up to a couple minutes. So the clients during that period are allowed to reconnect and reclaim previous state, if they're listed in that recovery DB, so just like with a normal singleton NFS server. And that lasts until the grace period times out, or all known clients have set a reclaim complete. So one of the reasons I'm focusing on v4.1 for this is that prior versions of NFS did not allow you to do, or did not send a reclaim complete. So you really had no way to know whether a client was finished with its reclaim. And so 4.1 allows that. And so that allows us to lift the grace period early if we know that all clients have come in and finished their reclaiming.
Does this mean a new client can't come along and mount if it's in a grace period? They have to wait?
No, you can mount. You just cannot do an open. So you won't be able to open a file. Okay. You'll get back NFS4 error grace essentially until.
Got it. Okay.
And the other thing, that we have to it's not necessarily the case that we are dead in the water during the grace period either. The only thing that's prevented is things that change the state, stateful information. So you can still do reads and writes, with existing file handles you had, or with existing files you had open. You don't necessarily have to wait for those. It's just state morphing operations are prevented until the grace period is lifted. Okay. So then we move into the enforcing state. So essentially, this client or this NFS server is finished with its reclaim. It clears its end flag, so it clears the need grace flag, but it stays enforcing. Now, if it's the last, if this one is the last end flag to be cleared, then we can fully lift the grace period, and we set R equals 0, so there's no more reclaim allowed, and we leave, and then we can also clear the enforcing flag, though I tend to do that in a separate step. At that point, we can clear out the recovery database in memory after the end flag is cleared, because we know we're not going to allow any more reclaim. And then at that point, we're sort of in limbo. We're not allowing any reclaim, but we're also not allowing any new state to be acquired either. So we just kind of, mostly we're just sending back errors at that point for any, for any state morphing operations that come in. And so once we transition to where the R equals 0, we know nobody needs the grace period any longer, and then we can transition to the next state, which is normal. And this is where the server will spend the bulk of its operations. Effectively, no recovery is allowed, so because R is 0, new state can be acquired now. We can do opens, closes, or we can do opens and locks and all that kind of good stuff. This is really where we spend almost all of the time for the server. It'll spend almost all of it there. And this either ends when the server shuts down, and at that point we go to shutdown state, or another node starts a new grace period. So another node may crash, come back up, say, hey, I need a grace period. And at that point, we go to the reinforced state. So at this point, another node another server in the cluster has said, hey, I need a grace period. But this particular node still knows what its clients are, and it doesn't need to do any reclaim. So what we do at that point is just enforce the grace period, but we don't actually allow any reclaim at that point. So what we do is we drain off any in-progress operations that would be disallowed during the grace period. At least that's the idea. And then we set our E flag and start enforcing the grace period. we also have to, because we're changing epochs at that point. The C actually changes when we declare a new grace period. So we have to create a new recovery database, and we write all our records for the active clients into it. That's okay. It's all done in a single transaction. So, and then the next thing we do is, and then at the end of that, we go back into our enforcing state, and then we can cycle back around and around in these states indefinitely. And so the last state is the shutdown state. This can technically enter for any other state. I mean, we could hit the start state and still shut down. At that point, though, we stop processing RPCs. We usually will declare a new grace period or join the existing one. We set our need and enforcing flags because the presumption is that we are going to be coming back up. And then we complete the shutdown. And what we want to do is ensure that the state's left intact in the Ceph MDS. Right now, Ganesha doesn't do this right. That's something I'm going to be working on here soon. But what it does is when we are shutting down the server, we want to make sure that we kind of want to leak all of our state, which is kind of nasty, but it's what the only way I can see to do this properly. So what we want to do is leave that intact so that nobody can acquire conflicting state, or state that would conflict with that state until we are back to starting back up again. All right, at that point now I have a demo. Let's see if I can get this to work. I may have to change. Hang on a second. May not work because I have to do it with screen. Hang on a second. Since my whole screen sharing is not working. All right. It doesn't seem to want to use my console windows. Yeah, I may not be able to do a demo over this thing. Sorry, guys. So in any case, you'll just have to take my word for it. It actually does work. So you can shut down the thing. I can, run IO against it, shut down another node in the cluster, and see it go into the grace period, and then it comes back out. Again. So, yeah, there's still a lot of work that needs to be done. Hang on, I've got one more slide, and I'll be done here.
Jeff, can we go back to the state diagram slide?
Sure. Which one?
Reinforce.
Sure.
During that reinforced state, are the Ganeshas able to, the ones that haven't failed, are they still allowing writes and changes to the files that are already open?
Yes. Yeah. That's the case even during a normal grace period. So even during the recovery phase, that's also the case. So reinforce and recovery enforcing, all that stuff. Again, the grace period really only affects state morphing operations. So you can open files, you can't open files, but you can do IO to files that you already held open. You can close files technically. I mean, some servers allow this, some don't. But technically, you are allowed to close files. You can release state that you held before. But what you can't do is acquire anything new, because that could conflict with stuff that we're going to allow to be reclaimed. Does that answer your question? Yeah. Mm-hmm.
And you can't open files because another server might have a conflicting delegation on that file that gave it exclusive write-back capability or whatever. Is that right?
Well, you can't do that because you can't open files mostly to allow for, delegations are part of it. Really what that is for NFS v4 allows you to do share locking, share deny locks. You can open a file and say, I want to set a deny lock, and then that will deny others from opening the file. This is a very Windows kind of thing.
Yeah.
So Microsoft. Yeah, so NFS v4, whenever they wrote the spec, they were really trying to entice the Windows folks to come aboard, and it didn't really work. So there we have some semantics in there that allow for that sort of thing. Now, most servers will allow that, will do share deny locking. I may actually make a proposal in one of the coming ones that we allow shared deny locking to be optional, because we can only sort of half-assed.
Yeah.
So you could declare that that it works. In practice, the Linux client never uses them. So
yeah, I guess it wouldn't actually. It wouldn't help because you'd still have to deny opens because you might have a failed NFS gateway that had a delegation, and that would also prevent you from doing opens, right?
Correct. Right. Yeah, that's the other thing. So delegations
doesn't make it worse.
Yeah. No, it doesn't. Yeah, we still have to do that even if we want to allow delegations, which we do.
Yeah. Okay.
So in any case, we still have a lot of work to do on this thing. Right now, all this relies on the MDS holding the state for us, for an NFS server that's gone down. So if Ganesh node crashes and comes back up, what we don't want the MDS to do at that point is kick out all the state and start allowing other stuff to acquire it. So we have to ensure that it squats on top of that state for a while until we can come in and give it an explicit, okay, you can release this now, which we do after everybody's enforcing the grace period. That's not properly done right now. I've started looking at how do we fix this, but it's not trivial. The other thing we need to do in Ganesha is grace enforcement should really be based on references. Right now, what we do is just check whether we're in a grace period at the beginning of an operation, but that's not really sufficient. We need to, because you could check for it and then go into the grace period, and then at that point, and then start doing conflicting operations after we've allowed that state to be released. And so we want to really make sure that we drain off any state morphing operations before we set our enforcing flag, and we can't really do that just yet. And Ramana and Travis are working on container orchestration integration right now. So I think Ramana has rolled a new URD for Ganesha and for Kubernetes, and we're looking at allowing it to building basically a way for Kubernetes to be able to start up a server that we need in a cluster. And eventually, we may want to redo the Grace database handling with OS. Right now, way I do this is with read, modify, write operation. I do a read operation, modify whatever the state is, and then try to do a write. And if something changed in between, we assert on that and then turn around and do it again. And that's not really that efficient. And we could do this with OSD class methods. In practice, it probably doesn't matter a whole lot. We don't hit the database that often. So, it's not really terrible. A little bit of inefficiency here really doesn't harm anything. So, in any case, that's all I got. Anybody else have questions? Okay. If not, I'll turn it over to Sage. Okay.
So it seems like sorry, can you hear me?
Yep, good.
Okay. So it seems like you really only need the enforcing state in NFS or in Ganesha if the MDS servers aren't already doing it for you, which I think they are unless they've crashed, right? Because, the Ganesha server holds the capabilities it needs for a client to have the delegation or open or whatever.
Right, but in order to reacquire the state, so let's say, okay, so server crashes. So we have a server and it holds a bunch of state for clients. It crashes, comes back, right? In order to reacquire that state, we have to kill off the state that was held by Ganesha before, by the previous instance. And that's a window of time when another server could come in, sneak in there, and steal that state from us. So that's why we have to ensure that we are enforcing the grace period during that time. Now, there is a potential optimization. The thing we could do is if we could teach Ganesha and the MDS how to allow reclaim of that state, right? If you could say, if it could instead of just killing off the old session, if it could just say, hey, hand me back all the old state I held before, then you don't have to put anybody else into the grace period because that state will still be held by that particular Ganesha. So it's something we could do, and we're looking at it.
Okay, yeah, because I know there were several different iterations of that, but I thought that one of them was already done and that you were relying on that, but I guess it doesn't work quite the way I thought it did. To do that takeover. I mean.
We started. So JUN did start doing some toward that, but it's not trivial. I mean, we have to do locks. You could potentially be shoveling a whole lot of state over the wire to the to the reincarnated server. And so it's a lot of there's a lot of work to be done there. And so the way I'm looking at it is that we may eventually allow that as a potential optimization. But for now, what we're going to do is do this one where we have these safer thing where we just put everybody into the grace period. And I think that's probably the right approach.
That's presumably more portable to other backends too, so I can see why that's good for NFS.
Exactly. Yeah.
Just wanted to make sure we hadn't lost sight of our other options completely.
Okay. And just to be clear, so the thing that we are doing with this is that the new Ganesha server instance, which is sort of a fresh SFS client, there are new calls where it can reassert, reclaim stuff that is in this limbo state from the previously dead client. Is that how it works?
So right now, what we do is we set sort of an opaque value on a particular MDS session,
mm-hmm.
and then, so there's state tied to that session, opens, locks, whatever.
Yeah.
And then when the server comes back, what we do is we declare, we say, hey, we want to kill off that old session. So we send that opaque string or opaque blob or whatever, and say, hey, kill off any old you have for this one. As part of this, what we'll do is we're also doing is we're allowing the Ceph client to declare, hey, I want a longer timeout, because the timeouts for a Ceph session are pretty short right now. They're like 60 seconds. So this is something that's actually useful even in an active passive configuration, because when because if a Ganesha goes down and you bring it up on another node or something, we don't want to have to wait that 60 seconds for the state to time out. We want to be able to kill it off and start things back up immediately. So it's a way for us to give the client some control over, I am this client, you can kill off my old state and start letting me do new stuff.
Got it. Okay, so the net new is really just killing off the old session, and then you just reopen it. Like if the client asserts that I had this file open, the new client just opens it, and it will be allowed to do that because we have no conflicting, because it's a cluster-wide grace period, so nobody else is going to. I think that makes sense.
Exactly.
That's simpler than I thought. That's pretty simple.
Yep. Exactly.
That's good. Okay. Awesome.
Yeah, I like it simple.
Yeah.
Anyway, I'll turn it over to Sage now, unless anybody else has questions. So.
All right. Thanks, Jeff. So I got a whole list of stuff here. I'm wondering what we should do first. I wonder if we should actually rearrange this slightly and talk about the REST API dashboard API thing first. Switch that around, because basically this is a conversation for Lens, who is still here. Yes. So big picture, that we have customers and users who say we need a REST API to manage the Ceph cluster. They don't want to use the CLI, they don't want to use the GUI ever, or they say something like everything that we can do in the GUI, we need to also be able to do through an API. And so we have a couple of different options. There's the old thing that just passes CLI commands over a REST API. That is also present in the new RESTful module. There's the new RESTful module, which implements like a small set of things, but it's very minimal, and there's no documentation, or minimal documentation, minimal functionality. It's pretty basic. And then the last option is that the dashboard itself internally has an API that it's using to talk to itself, to the manager, in order to do everything that it does. The problem with using that is that it's an internal API, and it's always going to do stuff that like a normal management REST API wouldn't want to do, like give you exactly the data you need to render some widget or something like that, which is just different. And we don't want to necessarily have at all the versioning and documentation hurdles or whatever for something that's internal to the dashboard. So I guess what are the questions? I think the question is, one, what's your sort of general view on all this lens? And what requirements are you seeing from your customers? And are we ready to sort of like commit to having like a separate REST API? And if so, who's invested in that, or are we not ready for that, or what?
So yeah, this is a recurring conversation. I hear you. And I can basically start by repeating what I've said before. I think we're not completely against at some point declaring the Ceph dashboard REST API as being an official API. The thing I'm concerned about at this point is that kind of freezing it down at this point will significantly slow us down, since we are still not feature complete and are still adding more functionality to it. Having said that, we actually do have that in mind when working on the back end. So I just merged a pull request, for example, that will give you an automated documentation of the REST API based on Swagger, which is a very popular tool for that. So that replaces an initial implementation of what we call the browsable API, where you basically can connect your browser to the API endpoint and then have a web page that gives you an explanation of what this particular endpoint does and how to use it. So by embedding documentation in the controller, you will then see this as a documentation on a web page. So the REST API will be self-documented in a way. And that also gives us a way of marking particular API parts as internal or maybe not stable yet. And the other way around, we can also set for things that have basically settled down and are stable, we can then declare this could be used by external applications. But at this point, the back end is still going through an evolution, and we really see the dashboard front end itself as the primary consumer. But as you said, there are, of course, some queries where you have to have a very specific JSON being returned in order to populate widgets, versus other more operative tasks like creating RBD or creating a pool or whatever. So we also try to separate out these more dashboard-specific API calls. So we definitely have this in mind. I'm not just at this point ready to commit to it being official at this point. So let's aim for having this as part of Nautilus. How about that?
Okay, so that's better than I thought. Swagger sounds awesome. So I mean, as long so that you're saying that you have the ability to mark individual APIs as internal or dashboard only or whatever, and so they'd be obscured or labeled as such if somebody is browsing the official API. All the authentication mechanism is like all general enough that it could be. I don't really know how people are normally using these REST APIs in the first place, but it's consumable. It actually like fits the set of requirements that you would expect out of like a generic general purpose.
Right. So that's
API.
an additional caveat at this point. The dashboard for now just is aware of one single admin user. You can freely define the username and password, but that user has full access to the entire REST API. We do have a pull request that's currently under review that will add roles and multiple users. So that gives you a way to define a user that, for example, just has read privileges to, let's say, RBD management or pools or Rados gateway, for that what it's worth. So that's currently being debated, and once that is in, well, then you could create maybe just an API user that has particular privileges for just the features that you would like to have. As a first stage, this will just be users managed locally in the mon config database, but also work in progress is adding not LDAP directly, but using SAML or OpenID Connect, so SSO protocols that are widely established. That's going to be the next step going forward. We're kind of moving up the stack here. But current, as it's shipped in Mimic, is just single user, single passwords with you can, of course, hand that over to any consumer that wants to connect to the API, but it would have a lot of power. And going forward, once you have roles, you can further restrict this down. And well, the API itself will also still continue to evolve. Yeah, so that's the current state of affairs. But in general, we are aware of the requirement of kind of the expectation being, well, there's this kind of nice REST API, can't we just make it official? Well, we are still very busy trying to shape it in and make sure that the front end, the dashboard front end itself has all the support it needs. So right now we print a big disclaimer that yes, of course you can use that API, but don't bet on it being stable or official at this point. So, we may be able to remove that comment at some point, but not right now.
I mean, nothing is official or stable until the actual release anyway. So does the Nautilus time frame sound like a good time to like say it's now ready for consumption?
Right. So the people working on the dashboard will actually meet in early July, and we will further discuss this topic as well. Both downstream representatives from SUSE and Red Hat have an interest in that, and so this is definitely one of the topics we're going to discuss further. But on a high level, this is our intentions and plans with that.
Awesome. Okay. Great. That's way better news than I thought. I thought we were going to have to actually maintain a separate API, but
yeah. Well, at some point, of course, once we declare this official, and we may have to make incompatible changes, we need to think about things like API versioning and all the other baggage that comes along with it. But for the time being, this is still very much in flux and evolving, so we don't even bother stabilizing or versioning it at this point, because right now we develop both backend and front end in parallel. So if we need to make changes, we make them on both ends and just commit. And as soon as you say yes, you can use this by other applications, you have some more liability. So that's the reason why I'm still a bit hesitant to fully commit to this at this point.
Exactly. Okay. Okay. All right. Well, that's all I had. I just wanted to raise the issue, but it sounds like if you guys are meeting in July, that's probably a good time to like lay out a more complete plan and timeline for when versioning is going to happen and so on. So,
It would help to get a better feeling for what are the most popular requirements and customer use cases. A full-blown API can do so much, but maybe is it about just creating RBDs automatically? Is that a low-hanging fruit to start with? Some more business intelligence or customer insight would be helpful.
The problem, I think the problem is that the requirements that I've seen so far, the ones that actually like are specific, are a combination of like non-specific and arbitrary. So they just want something like thou shalt be able to do everything via the API that you can do through the GUI.
Right.
Which is like, okay, whatever. And then they also wanted it to be based on the old REST API, which like makes no sense.
Yeah, that's definitely.
I think a lot of it is just like it's sort of a checkbox requirement where like there must be a management API that they can consume.
Understood.
But they don't have a strong sense of what it needs. So.
Right. Yeah. That's the thing I'm concerned about. If it's just a checkbox item, well, sure, we can say yes, we have a managed REST API, but if there are more particular expectations, we would love to hear about them.
Yeah. Agreed. Okay. All right, cool. Any other comments, questions, thoughts on the API stuff? I don't think we have. Yep. All right, thanks. Next up is the smart prediction of device failures. I want to give an update on that. This is a project that's gone through several iterations now. It started with a outreachy project with Yarit, who's on the call, to do some built-in capabilities in Ceph to monitor smart statistics and predict device failures and respond to them. It's evolved somewhat since then. I think that the way that I'm thinking about it now is sort of into grouping into 3 sub-problems. The first problem is the metric collection. And there's a bunch of work that Yuri did initially with SmartMon tools, so that will output a JSON dump instead of this like horrible thing that you have to parse, which is what Smart Control does now. And then there's also an OSD command that you can do. You can do tell, Ceph tell, OSD, whatever, smart, and it will basically do a Smart Control JSON dump on every device that it's using, and it'll send that back to you. So it's sort of an in-band, built-in way to collect smart metrics that doesn't require that you deploy your own Prometheus thing or other agents or whatever. So there's that piece, and that's more or less complete, except that the SmartMon tools changes to output JSON are still like going around in circles on the SmartMon tools upstream. They're like semi-complete for, was it like SCSI and SATA, but not for NVMe or something? I can't remember. And so I'm not really sure what the release timeline looks like for that, but that's sort of the blocking bit on that end. In the middle is something that will like iterate over all your OSDs and scrape the metrics, or over an OSD, scrape the metric and like predict something about whether the device is going to fail or not. There's a sort of a proof of concept module in the manager right now that does that. Well, it'll scrape the OSDs and it'll archive them in Rados. It doesn't actually do any prediction yet. But that's sort of a, let's call that middle part the prediction part, and it's sort of a black box for now. And then the last part of it is like, what do you actually do once you have made a prediction on how long a device is going to last? And that's the bit that we're working on most recently. If you look at the smart pad or the Etherpad or whatever for this, pull request that is, I can link to here in a moment, that basically adds reporting from the OSDs and the metadata of the devices that an OSD is consuming with a unique identifier that's like the vendor and the serial number and other things that are actually uniquely identified device. And then there's a bunch of code in the manager that parses that and implements some commands that let you list devices. So there's a new Ceph device list command that lists all the unique devices in the system. You can query info on a device that tells you which daemons are consuming it. And you can list devices by host and by daemon to tell what the dependencies and interactions are between physical devices and the daemons that consume them. And as part of that, there's the ability to basically tell the cluster to store the predicted lifetime of a device. So assuming that middle black box says that this disk is going to fail in 4 days, you can issue the Ceph command that will say, set predicted failure of this device in 4 days from now. And the cluster will store it in a same way. So that's what this pull request is. And then the last piece is going to be, as the next part that Yuri's looking at, which is basically the automation that does something about it. So it'll basically look at all the devices and when failures are predicted to happen, and it'll say, oh, this disk is supposed to fail in 4 days. I should do something about it. Maybe that's raise a health warning. Maybe it's mark the OSD out, offload data from it before it actually fails. Maybe it's, set the primary affinity, whatever policy and sort of automation stuff we want to do is going to sort of live in that last piece. So that's sort of the lay of the land. The interesting bit is in that middle part where you actually have to predict something. At the same time that this whole sort of building something into Ceph was going on, started getting aggressively contacted by a company called Profit Store, who has a product called Disk Profit that's like an AI-driven, very smart, very accurate tool that will predict when your disks are going to fail. They have a product you can deploy on premise, and then they have a SaaS service. And they want to offer a free version of that SaaS service where you basically query an API, you say, these are the metrics for this unique device, and it'll tell you when it thinks that device is going to fail. And there'll be a free version that's like pretty accurate, and then if you pay them, you'll get like a really accurate version. And so they've written a manager module that needs a bunch of work, but there's a sort of a draft implementation that sits in that middle part that will basically use the OSD command to scrape the smart metrics that your rate implemented. It'll push them to the API, get a prediction, and then right now it like does something stupid like store it in a file, but it will then pass it off to the device tracking to store that predicted failure so that all the Ceph bits can actually respond to it. So once all these pieces are there, that sort of middle gap will be filled by, or could be filled by a module that queries this disk profit SaaS service, or if you deploy it on premise or whatever, which would be pretty cool. And then because it's sort of broken into pieces, the idea is then that middle piece could also be implemented by something else. So if somebody has an open source failure prediction model code library, whatever it is, then you could use that in place too. And all the bits that teach the cluster how to respond to a predicted failure don't change, and probably the bits that are actually collecting the data don't change. It might be that you don't want to use the piece that's collecting through the OSD either. Maybe you already have, like Prometheus is already scraping these things and dumping them in a time series database. That's fine. You could also pull the data from there instead. But that last end of the pipeline where you say, I know that this device is going to fail in 2 weeks, and the cluster responds to it, remains the same. So that's the big picture. A whole bunch of like missing details there. Any questions or comments on sort of what that looks like?
I like the idea of the OSD pulling the smart metadata itself. That makes it actually a lot easier with regard to, say, containerization, where getting at that container with a Prometheus probe is kind of annoying. So being able to pull that from the OSD is cool. I think the one part in the pads that gave me a little bit of a heart attack was when you read, or when it says that it will store the smart metadata in a dedicated pool, including history. And I'm like, are we is this maybe scope creep?
Yeah, right.
That's not. Why? So maybe that was considered and discarded, and I couldn't find it. But why? So if I ask an OSD for its metadata, it will already show me its current metadata, right? The OSD metadata dump. Could that not be the place to store the transient and the latest version of the smart data, and then we store it wherever?
Yeah. So that part of the spec and the implementation was sort of the old plan, or the original plan, before the disk profit thing happened, and you start thinking about the second half of it and how you could fit it in and have that part be pluggable. And so right now, that bit of the implementation of spec is sort of possibly useful in that middle area where that's sort of the black box that where you do the prediction. So again, the way I'm viewing it is there's the first part where we have some tools that let you scrape the data, and that's generic, and you can use them or not use them. And then we have the infrastructure to store the prediction and to respond to it. That'll be totally generic, and everything in between is sort of TBD. In the disk profit case, their module is going to do all of that. So it'll directly scrape the latest metric and query their API, and on their server side, they're going to be storing the history, and they're going to be running AI machine learning stuff all over it. They're going to be doing all that, and they'll just give you back a prediction. And so Ceph doesn't need to do anything. It just needs to say, here's the device, here's the latest metric. Is it going to fail? The goal, though, I think, for the community at large should be that there should also be a completely free and open implementation of that part of the pipeline. And so the thinking when we were speccing out that Rados bit was that there should be a module that's in tree that is, maybe it's not a very high quality, but it's a disk failure prediction stuff that exists in Manager that you just turn on. And in that case, we do need to store some limited amount of history in order to like run some basic model to decide whether the disk is going to fail. And so that was what that Rados pool is going to be used for. But whether that's how it's going to be implemented or not, like, I'm not sure.
Okay, that makes sense to me. I would. So my initial feeling is that whole model running, probably even a very trivial model could run in the Manager, but maybe even for the free editions, that could be something that is a little bit out. Not everything has to be in Ceph Core,
Exactly. Yes.
For very for Flash, it's easy, right? As soon as you have 2 data points, you can. It's just Flash actually predicts very well what will fail. So okay.
So the other part of this is that the other dimension of the conversation that we had with Profit Store was that what I originally tried to get them to do was to define a completely generic API where you would post the metric and then get back a prediction. So that the thing that was actually sitting in Manager pushing metrics and getting a prediction would be totally generic. And then somebody else could just implement a compatible server that implements that API that runs whatever model and whatever backend storage or whatever they want. And that's still an option. And I think that might actually be what they're doing, because we talked about this in the Ceph leadership call last week, I guess. There's some concern about having a Ceph manager module that's in the tree that's like called disk profit. That's like a commercial name that's tied directly to a SaaS service that's a commercial service, a money-making service. And so what I suspect is going to happen is that module is going to be like completely genericized, non-vendor specific, and the API that it uses to query the SaaS service is going to be specified, so that somebody else could implement another model that just implements that API. Right. And on the back end, it'll use whatever time series database and AI model, whatever it wants.
Right, so that's actually some overlap to the telemetry stuff here, obviously. Interesting questions that would be if that, just curiosity. So when we store that data, right, and that data, the predicted failure date, right? Mm-hmm. And that data came from Profit Store, Profit Disk. Yeah. Mm-hmm. Can we then say, if we were to send that data back as part of telemetry, is that violating someone's intellectual property? Just one of the things that probably at some point should be asked, how proprietary is the data that's then in the metadata of Ceph data? Anyway, but that sounds cool. Yeah.
I mean, it's literally a timestamp. All I'm storing is a timestamp and the time that you recorded the timestamp. So it's not that much. And it's not something I would ever expect telemetry to send. Telemetry should be sending back like anonymous aggregate data and not anything specific. So I don't think those overlap. But yeah, the whole brave new world of GDPR, we have to pay a lot more attention, I think, than we used to. But yeah, I guess just big picture again, I think there are two sort of pluggability options here. One is that you could make a completely different set of tooling. Maybe it's a manager module, maybe it's something else that scrapes metrics and predicts something and feeds and tells the cluster when things are going to fail. Or also the module that Profit Store is working on is querying an API that I'm pretty sure they're gonna go down the road where they actually specify that API. In which case you could also reuse that existing module and just implement the server side of that API. So I think there are two different ways that you could have different pipelines or whatever to feed this prediction data back into the cluster.
Yep, that makes sense.
Cool. Any other questions or comments on this? I'm pretty excited about this feature in general because I don't have hard data on this, but the risk, your data durability risk is generally related to the probability of having a second failure or correlated failures in your system. And if you can re-replicate data, create a new replica before the failure happens, I expect that we're going to get order of magnitude, hopefully, increase in the overall reliability, probability of data loss in our systems, which is going to be I think this is going to be a pretty big increase in overall system reliability, at least from hardware failures. Software failures are another thing. Yeah, I'm excited.
Yeah.
From a dashboard.
Oh, sorry, go on.
Yeah, I was just making a comment from the dashboard perspective that, of course, it would be very nifty to being able to obtain that information from the manager directly, so we can also visualize it there.
Yep. absolutely.
Yeah, and in general, to contribute to open data. It's one of the purposes that we have in mind.
Yes. Yep. Yeah, there was a, I don't know if we socialized it on very publicly, but after the Vault conference last year, this whole conversation started about the idea of building a public data set of smart failure data. Because currently, if you want to like get data to train these models, you have to go, either Backblaze as a data set, or you have to like sign an NDA with like Google or something to get some big cloud providers data set. But the big question was like, would it be possible to make like a publicly governed public data set of smart data where you have an API that you can feed smart data to, and as sort of the carrot to get you to share that data, you would get hopefully good failure predictions out of. And that fits like perfectly into this overall model. Like if you take the API that DiskProfit is implementing, you could just point it at like, publicsmartdata.org or something like that, and you'd hopefully have some like good governance around that, and people would actually trust it. But then you could get like a big data set with a broad range of disk vendors and all that stuff, and build a very accurate model. Basically the same thing that DiskProfit's doing, but sort of an open data, open model sort of thing. I don't know how the last person to really run with that was Patrick. He's off at data.world now. I don't know if anything's really happening in that space, but at least all the other pieces are sort of in place so that somebody could go off and do that.
Just a question, Sage. So is Profit Store actually willing to dedicate an engineer to work on the Ceph part for this? Or haven't we had the discussions yet?
They've written like thousands of lines of code. Yeah, they've got like several engineers, I think, working on this. They're like super eager to make this a thing. Yep.
Is that already public viewable somewhere? Is there pull request?
Yeah, okay. Let me look at the. Let me find the pull request. You can go look at the DiskProfit. Here it is. Here is the pull request that they published so far. The pull request needs a bunch of work because it predates this tracking of devices and storing the prediction stuff. And so it's doing a bunch of things that aren't quite right. But this is, yeah, how many lines is it? It's 3,000 lines of code currently.
All right. Cool. Thank you.
Yep. Exciting. All right. Any other comments, questions on that? Okay. All right. Thanks. Let's see. Tracker. What's next? Crash reports. Okay. So we talked about this. I think it was in a CDM, but I couldn't find it on the agenda of any of the past ones. Maybe we're just talking about it in a stand-up. Here's the pad. The idea is that we would modify, and I just like made a very specific proposal just as a straw man proposal to facilitate discussion. So tell me if there's any of this is stupid. The idea would be to modify the current segfault handler that dumps recent log files in a stack trace to the log file to also generate a crash directory report in varlib somewhere. So I'm thinking varlib ceph crash and then some unique identifier for that particular crash. And it would be broken out into several files, so it's like easily parsable, understandable. One would be that same log dump that we put in the log. So the last like 10,000 lines of log or whatever it is. One would be the name of the daemon. One would be the stack trace, just that little stack trace section. And then I was thinking maybe the dump of the config options. I couldn't think of what else was like fully generic to put in there, but basically just a record that this daemon crashed, and there it is. And the problem this is trying to solve is that like if your daemons crash, they'll dump something in the log file and then systemd or whatever will restart it, and then you don't actually notice. Like there's no persistent record that server crashed unless you happen to go read the log file, which nobody ever does, or you have something that's monitoring your log file. So this makes it like a distinct record of that crash. And then we'd have some helper that would just that would look in that directory and look at all the crash reports, and then it would basically report them back up to the manager. So it'd say, manager, I have crash report this UID. Have you heard about it already? If not, it would upload whatever information it has about it. And then it would mark it on the local node as one that's already been reported, so it doesn't have to repeat that process every time. And probably that helper would just run on every daemon when it starts up. So every time a daemon starts, it just also looks in the crash directory to report any previous crashes of previous instances, so that we sort of hoover these up opportunistically whenever possible. The manager module would store those crash reports in config key probably. The logs are going to be big, so maybe those have to go in a Rados pool, or maybe they wouldn't even be stored by the manager at all. I'm not really sure what makes sense. And then maybe, I think the real win would be if we take the stack trace portion of that and strip out the like the code offsets. So it's just the function names, which is still pretty unique. It should be sufficient to like pretty uniquely identify a particular crash.
I think
so
you
you normally
want to keep those offsets. Like
it
we've
could
actually
be.
seen different causes in some of the, not many of them, but some of the same functions will have 2 or 3 different asserts that actually get hit and are not the same root cause.
Yeah,
I think we want to be able to distinguish between that.
My only concern is that it would be nice to capture the same crash across different builds. And so if you have like 20 different builds out in the wild, it would show up as 20 different crashes if they're different builds, because those code offsets would be slightly different.
Yeah.
That was the reason. We could do both.
I mean,
either way.
Or you can always filter that server side, right? Yeah,
that's true. Yeah, you can filter server side, right?
Be a little leery about doing that much in a signal handler. I don't know if that was your intent here, but you may want to do like have the signal handler kick off something else to do all the work, because doing stuff like that inside of the signal handler, especially in a SegD,
right? Yeah,
you get memory corruption and stuff. So that could be nasty.
Well, this proposal is that the signal handler would just write out the files and then it would exit.
Yeah,
the file writing is a problem.
Writing files and stuff is could be pretty involved. So
yeah,
and you have to work. You may want to. You probably need to protect it and do all that kind of stuff as well. So they're dragons in that kind of thing. So
yeah. So what we do right now is the signal handler already does the log dump. So the signal handler already does, it generates a stack trace and it spits out the last 10,000 lines of log in memory, and it dumps all that to the log file. So it already is doing a bunch of this, and we just make it so that once we enter the signal handler, we reset the handler so that if there's a segfault in the segfault handler, it just will give up and do nothing. It'll actually just crash and core dump. And so far that seemed to work okay, I think.
Good for you.
Every once in a while, we get like a secondary crash inside the signal handler, but it doesn't happen that often. It's usually when there's a bug in the allocator or the logging code itself. So my hope is that writing the same file to a new file handle instead of an old file handle won't be that much of a delta. But I gather that that's a lot more than what most people do in their SegV handlers. So, anyway, okay. So what do you guys think?
It would be great to have this information.
Yep, it would be really great. As far as how that's implemented, are there suggestions on ways to do it differently that would be better?
The question of doing it in the signal handler is valid. I mean, we could also look at analyzing the core dump after we have been restarted, but I think it's probably easy this way, so it shouldn't be too bad.
I think not all systems actually save the core file.
Or they're being passed off to other programs, so we don't necessarily
like app forward or something.
Yeah.
Yeah, this works even if core dumps are turned off, which is kind of nice.
We should maybe investigate what we can do in the systemd unit, because they do have like post-exec stuff, I think. So it may be that we can tell that to capture the core dump somewhere, even if it's turned off by default for the system.
Yeah, or it could be,
and then
we could kick the thing that reports crashes. We could have like Ceph crash reporter that goes and scrapes file of Ceph. That could get kicked off by systemd.
Yeah, and that sounds better too, because you could just have the signal handler kick whatever it is that does the work, rather than doing it all inside there.
I don't know that we can get away from the signal handler writing out this information without capturing the core file. That's the thing. And I don't know how to analyze. I mean, maybe it must be possible, but I don't know how you go and automate. I guess you could like scrape GDB or something. I don't know. I don't know how you automate like analyzing a core file to like. Obviously it's gonna be done, but.
So KDE does it. We are actually running GDB, which is a major pain because that then complains a whole lot about missing. Anyway, the other thing might be looking at what Mozilla does. Maybe that is interesting because they gather crash reports as well. You know, maybe just for comparison and inspiration if they have any good ideas.
Yep. Yeah, I guess my worry is that we start introducing a lot of dependencies on how the system is configured. So some systems will have that appert thing installed that's like all the system-wide, all the core files are getting piped to. I don't know how you override that on like a per systemd unit, or if you can. And if we do that and we pipe it all to our special crash collector, do we then also feed it to the, I don't know, it gets all messy. Whereas the signal handler that we have right now is already doing almost exactly the same thing. It's touching all the same data structures in memory. So this isn't making it any more fragile than it already is. And we haven't had problems yet. And I think the worst case is that you crash trying to generate your crash report, which means that you just don't generate a crash report. So that's like no loss.
Well, you're writing out files, from within a signal handler where you're dealing with potential memory corruption. So who knows what you're going to scribble over on the file system? So that would be my real concern there, I think. And that you may have that problem now. So I don't know.
Yeah.
I mean, is that exploitable? Is that?
I guess the difference is that. Yeah. Go ahead.
I've done something like that in a previous life with an HA stack. It's not that you change routes, the signal handler and stuff beforehand. It's not that, or you open the files and everything ahead of time. It's not that bad. And especially if it's containerized or otherwise constrained, you just can't scribble over everything. So not usually, it hasn't been a concern for us in the past, at least.
Okay, fair enough then.
Maybe a true is probably a good way to help protect ourselves. I think that the net new here is that what the current handler does is it writes to a file descriptor that's already open, whereas this will create a directory and write to several new files in that same directory, but the actual data that's writing is roughly the same. I guess the config options are net new, but if we chroot into the directory that we created before we wrote those files, then like even if we start writing random memory, then like it's pretty, I don't know, it feels moderately safe.
I'd just be worried about if trying with the core dump path of trying to capture those core dumps, since they're so large, just having them able to fit on the file system locally, or if we wanted to do anything else later, running out of space because we kept crashing or something.
Yeah, this tries to keep them small. What do you guys think about collecting the log centrally? Because most of the stuff is really small except for the last in log lines.
Yeah, I mean 10,000 lines isn't that long compared to a whole debug log. So I think that makes sense to collect if you can, but it definitely needs to be an opt-in thing because that can have information about object names and whatever else.
Yeah.
People are going to be a lot more sensitive about that probably than just stack traces if they're submitting it to us?
Oh, you know what? Sorry, what I meant to say is collecting those logs in the manager. I wasn't actually thinking about phoning them home through telemetry.
Well, so I mean, there is a point to that, but it's pretty limited if it's only in the manager and not getting centralized, right? Because I guess it means the admin can look at the log lines without SSHing to the server, but I don't know that they care about that.
Unless we eventually have some kind of like crash analysis area of the dashboard that you can go in and like look at these crashes that have occurred in DMITs and logs, but that doesn't seem like it'd be super helpful.
Yeah, it kind of makes me think that it's not actually adding any much value. It might not bother doing it. So we could leave the log on the local crash directory, and those get deleted after you have like 10 of them, or they get more than 10 days old, or some retention policy. But then only store the stack traces in the manager, and only phone home the stack traces.
Yeah, I think
yeah,
we
I
want
think
to
that
try
makes
to
sense.
keep like unique stack traces rather than just a cycle, but because sometimes something will go wrong and then it'll scribble over and you'll crash on startup every time, but you want the original crash that actually caused the issue.
Mm-hmm. So that would show up as like 20 instances of the same crash or whatever, same stack trace. But
yeah, well, I mean, sometimes it's like stack trace A is the actual problem, and then stack trace B occurs
subsequent
on every
startups.
So you want to have A and B in the log.
Yeah, I mean, I think they would be. In this case, they would show up as separate crashes. So we'd probably want to make sure that the daemon who crashed is also uniquely identified. So we'll have a cluster. We'll have a cluster ID. We'll have a daemon ID, and we'll have the crash ID, I guess, and those will be associated. So when you look at that particular crash, you'll see, oh, there were like this particular daemon crashed 50 times in the one way, and then right before that, it crashed this other unique way. And you could also see that, oh, the same cluster had like 7 other OSDs crash in the same way at the same time, or whatever it is. Assuming we phone all that information home, which I think would be nice, but if it's with the telemetry module, it's a unique ID that's used only for the purposes of telemetry. It's not actually the cluster ID, but it is unique to the cluster that identifies all the telemetry from one cluster. So, and the telemetry user can choose whether or not they identify themselves or not. They can optionally set like, I own this cluster, so if we want to go contact them or not. If we wanted to get really fancy, we could have a feedback mechanism whereby telemetry could be operating in a fully anonymous mode. But if the developer sees an interesting crash and they want more information, they could just flag that, set a flag on that ID that like they request more information, and the next time telemetry dials in, it'll say, oh, it'll pass that message back and it'll show up for their, yeah, who knows.
I have a feeling people wouldn't like that one as much.
Yeah, the developers want us to hear about your crash, but we don't know who you are. Please contact. Yeah,
we could include a Bitcoin address they can pay if they.
Yes, perfect. Okay. Anything else on that? Feels like the. Yeah, go ahead.
So I have 2 things. Did we talk about BreakPad at all? The Google project for generating the.
You brought this up last time, and I forgot about it. Yeah. I have not.
So that might be something else to consider. I don't want to try to do runtime analysis of that, and I haven't played around with it personally. Another option for generating core dumps, apparently ptrace recently added an option to dump core on what you're tracing. And so one possibility is we could have a wrapper process that runs Ceph traced but it doesn't intercept the system calls. It's just waiting for an exit event, or in particular a stop created by a fatal signal, and then just do a dump core on that, and then that ptrace command lets you specify a file you want the core dump written to, and so we're still getting our core dumps in the right format, and there shouldn't be much or any overhead because we're not intercepting any real events from the process except for when it stops. So that's another possibility for doing it, and it should be pretty simple.
That sounds more robust, definitely. And presumably it could choose whether it actually dumps a core or whether it just examines the in-memory state to generate whatever stack trace it needs and then throws it out, or whatever it needs to do, right?
Yeah, I think you could even run GDB with a certain set of commands to generate the things you want.
Yeah.
And then also there's that issue that I had written where we can have the OSD tell the kernel which memory segments not to dump for security purposes, and also just to keep the core dumps a reasonable size. We can use that. Also in tandem with this to limit what we dump and make it safer.
Yep. I'm not sure if we know where actual buffered cached user data is going to end up in memory very easily, but that would make sense if we were going to capture cores. This actually isn't proposing that we capture core files at all. It's just capturing the stack traces. So it would just tell us like what versions of Ceph are crashing and where, and that's it. But we should definitely look at that break pad thing. That looks potentially interesting. When did we talk about this before? Because suddenly all of your suggestions, we talked about this, but I can't remember when it was. Was it in a CDM before, or was it?
No, it was a mail thread you started capturing crash dumps on February 19th.
Got it. Okay. Perfect. I'll go reread that too. Okay. Anything else on that one? All right. Cephfs georeplication. Kind of wanted to. So I've been thinking a lot about this general topic because I think it's one of the main features that we're missing that is going to be important in sort of the multi-cloud federated whatever world, especially one that's emerging with Kubernetes and deploying applications across multiple clouds and private clouds and whatever, making them all behave. So I tried to lay out what the motivating use cases are, what some other implementations of this look like, and figure out what we should do. I should mention there was a thread on the mailing list, I guess last month. I'm forgetting the person's name who wanted to implement this. He talked at the last CDM actually proposing to do the Rados level georeplication, but it turns out that the motivating use case was really around Ceph and doing Ceph stuff, so he's interested in working on this. So I wanted to lay out what the motivating use cases were and see what I'm missing, and then real implementations, and then some possible paths that we can take. So use cases are just disaster recovery, where you have multiple clusters. If one of them blows up or the data center goes away, you want to have a usable backup copy at another site. Part of that probably would be failing back, so when that data center comes back, you can resynchronize and continue without re-replicating the whole data set. So disaster recovery is one. Active passive replication would be one. I'm not actually sure how common this would be, but basically you would have multiple clusters. You would always write in one, but you'd have a replica of the file system in another location that you could read from, but you couldn't write to. I think it's not that different from the disaster recovery case, except you might want it to be more up to date as opposed to a periodic backup style replica. And then the sort of the holy grail would be an active case where you have 2 replicas of the file system in 2 different sites. Updates happen sort of locally, but they're then asynchronously propagated to the other site. Well, you tell people that you have a new distributed file system, they start asking about like whether you can have a globally distributed file system with replicas in different parts of the world and like have data follow the sun and always be cached locally and all this like crazy stuff that is basically impossible to do in a way that is fully consistent and performant. So this is sort of reaching towards that, I guess. And obviously consistency and conflicts are the big issue there. So am I missing, are there other use cases that make sense there? Am I missing something? Or does this make sense?
These make sense, but I think maybe we need to drop the Dropbox functionality as a target.
Under related implementations?
Well, I mean, so you talk about bidirectional active-active at the end, and you're like, wow, or well, maybe someone else wrote this, but it's complex and hard to explain to users, as is noted. And like usually when you have an active-active, what you've actually got is something like AFS, I think, where different sites will take over trees and will maintain authority for that tree. And then if someone else on a different like site wants to access one of those files, they do the remote access. And they just pay the latency cost on it. But usually it's a tree is in a location and they do asynchronous replication of changes based on the master for a portion of the namespace.
What would we call that? Is that like floating master by a tree or something?
I mean, I'm saying that I think that's how you usually implement active-active. Is with, I mean, that's Andrew FS, right? The thing, like the old university file system where you delegate it down through the servers to someone's desktop and and I'm not sure that that's a thing we're ever going to be good at, but if it is, that's like the design. I mean, maybe we could be because we have the capability, so it can be a more permanent capability system, but I think that would be the way to do it if we wanted to do it, not try and like do some weird conflict resolution system.
Yeah. Well, okay.
No one's ever made those work. Like they try, and it's bad if you say that it's actually active-active.
Yeah. So our primary use case that we see clearly would be well served by active passive replication based on snapshots. As long as the target is in a consistent state, we can make that work. If we can optimize it so rsync actually finds stuff fast, that goes a long way towards meeting that goal. And then they could make that, if they wanted to go down that route with some active manual load balancing things, they can always have different directory trees that they, replicate in different directions and manage that separately outside our control.
Yeah. Okay. Well, so what I was trying to do is sort of break apart the use cases and what the users are actually trying to do from how it's implemented, because I think I basically completely agree with what you're saying, Greg, except that I think it's like you can't do active for multiple sites with writers like in a fully consistent and performant way. But the way that people or conflict resolution in a general way, but the way that people sort of address that is by taking the pessimistic view that we're going to like never allow conflicts to happen. And I think in reality, for most users, like conflicts don't happen. Like it's not that you have 2 people editing the same file in 2 geographic regions. Like maybe that'll happen like once in a blue moon, but like 99.99% that like isn't actually the case. It's that you have different applications operating on completely different parts of the tree. And so what I'm wondering is if there's a sort of a more optimistic replication that has some basic conflict resolution that is going to work.
I think most of those use cases, though, are satisfied
that's
and the
what I want
Dropbox
to capture.
thing that you talk about is usually going to people not using Ceph directly. It'll be a user like syncing their files to their cloud, and so you have another program in the way anyway before you reach us. And so that again is more of a active passive sort of backup thing.
Yeah, but right. So I think that
basically what I'm saying is we should focus on the rsync case, and then we can like
yeah.
do more tooling around it to say, okay, now you can sync only this tree in this direction and this tree in the other direction,
Right.
and yeah.
Yeah. Or have
No,
some
no.
orchestrator that automatically does all that.
Yeah.
I have a dumb question. Can we use RGW sync modules to do the sync? Like, you know.
Maybe, or something like analogous. I think that the main thing that's missing right now is well, I guess there are a couple different ways. Is how to identify what the changes are. The RGW sync modules have that like change log in the buckets. We don't have the same thing in CephFS. We have to like scrape or traverse.
That's true, but you know, like similar to the sync from cloud that you know you don't have a list of changes or anything. You can build it or do something that builds that, and that's like looking at the extended attributes there, stuff like that periodically, and build stuff out of that.
Yep. Yeah, so maybe the way to approach this is to have a similarly module-based sync framework. Well, okay, so what I wanted to do is catalog a couple of the solutions that are out there right now, just as a point of comparison, because it feels like we haven't like thought about this or like seriously considered implementing things, because like solving the entire problem perfectly is hard. But it turns out that you can solve it imperfectly with easy solutions, and that actually will capture like a lot of use cases. And there's nothing really preventing us from doing it. So, so one point comparison is the GlusterFS gReplication. This is basically on the back end, it's rsync, but it's driven by a changelog that the nodes are generating. So they're generating a list of files that to examine, and the rsync background thing just sits there and rsyncs those specific files. So it's loosely consistent. It's only useful for DR because it's loosely consistent on the other side. It's one directional. Although I guess you can chain them too. You can have like A to B and B to C. But yeah, so it's relatively simple to implement, assuming you have a changelog. One that's widely deployed commercially is the NetApp SnapMirror thing, which takes a snapshot every few minutes. I recently, Uday mentioned that the shortest interval that you can configure is 5 minutes. That's just because the design doesn't really scale down to smaller time frames. But you just periodically take a snapshot and then sync that snapshot to the other side. This is interesting because it's something that we could pretty trivially, I think, do just by like taking snapshots on a schedule in CephFS and then doing an efficient rsync cross. And then once we've finished rsyncing the snapshot, take that same snapshot name on the remote site. And it might even be that we can operate more efficiently than NetApp does, because it has to scan its like snapshot bitmaps for changes, and we would do the same thing in the namespace. Depending on how many changes are, I guess that may or may not be more or less efficient. GlusterFS has this Halo replication thing, which is super weird, and I don't really understand, but it's sort of a weird mix between synchronous and asynchronous replication. It basically works as long as your workload is like behaving in a correct way, but if you are writing to the same files in multiple sites, then you get split brain, and things go bad. So, and then the one other thing I wanted to mention is that I think that actually the biggest example of distributed write replication is actually Dropbox, which isn't really at the file system level, it's at the file level. So you have totally disconnected operation. When you reconnect, then it just like checks in a new version of the file, and the server side just keeps multiple versions of files, revisions, as part of its existing archiving thing. And so if there was a conflict, you can just roll back to the other one or the conflicting one, and it's probably flagged in the history or something like that. but that to me is sort of a proof point that like conflicts are rare, although not that rare. And as long as you have a way to resolve them and like identify them, then like that's the user experience for that like is okay. It's not that you have to like magically resolve a conflict between two programs modifying a database. It's that you have to resolve conflicts between humans editing a Word doc. And so, right, so there's the rsync piece, which is what the fellow's name I forget is working on now, I believe, which basically just makes rsync scan CephFS hierarchies more efficiently. I think there's actually a key piece of work here that we have to do because the rstats don't propagate synchronously. And so I think in order for this to actually be reliable, we have to have a way that like forces a flush of rstats up to a particular point of the tree where you're starting your sync. But my memory here is pretty hazy. Patrick, do you know what the state of this is?
Forcing a flush of the rstats?
Yeah.
I imagine a snapshot should be enough, but you know that'd be a question for Jung, I think.
Yeah, I think you're right that we don't actually force it, but there's little reason not to because we are doing like synchronous flushes of all the data anyway. So I think we just need to make the MDS do it before it writes out the snapshot data.
Yeah, or before you can snap the snapped directory, the rstats have to have propagated up or something. Yeah. That would be ideal if it just says transparent. Okay,
but
so
yeah, it shouldn't. I mean, I haven't looked at this in a very long time, so take it with a grain of salt. But it shouldn't be too hard to force. We'll need to get someone to do it.
Okay, because I think if we did that one piece in the MDS, then we could do the snapshot-driven snap mirror type thing where we just have it could be like a bash script that just takes a snapshot and rsyncs across, and then takes a snapshot of the remote side. I think we could have that solution, which is like equivalent to what NetApps do. Should be pretty good, with almost without any sort of deeper surgery or plumbing. And that would give us a DR solution that's strongly consistent, which would be pretty nice. Okay.
Just one quick note there. Could we not call it snap mirror? Because I'm pretty sure that's going to be a trademark.
Yeah, definitely not. Yeah.
Okay.
Yeah, I tried to be careful to say snap mirror only next to NetApp. Yeah, we would want to call it snapshot driven DR or something. That's what I wrote. Yeah.
Doesn't CephFS keep the data and metadata in two different pools? So which are you snapshotting?
This is a CephFS level snapshot. So this is operating at the POSIX API layer.
Oh, so it handles that then?
Yeah, it's consistent and it already exists.
Yep. All right. Well, so the last bit is my sort of waving hands at the idea of having active-active mirroring. So one idea would be that you just allow writes in multiple locations, and you are asynchronously replicating those writes to the other side, and then you would have some sort of automated conflict resolution. So something like last writer wins for files and first rename wins if the renames conflict, something like that. This has like, in order to actually implement this, we'd have to have a changelog, I think, to stream those updates across. But the sort of idea would be that if you have, if CephFS was able to have a way to track multiple revisions or forks of a file, so that if you had conflicting changes on multiple sites, it could preserve them on both sides, and then you could resolve them by reverting to one or the other. Then that might actually be like a sufficient user experience for a lot of use cases, right? Because everything would appear to work. If you did something totally weird in multiple sites, then it would recover automatically, and you could sort of recover manually the other way if you needed to. That's the sort of the social user hypothesis, I guess. I think the other one here is what Greg was talking about, where it's like subtree driven, subtree based masters per subtree masters with unidirectional sync.
Yeah, I get why the Dropbox thing appeals to you, but I think you need to keep in mind that they have a lot of stuff that we don't. They keep, like, because they're a user thing rather than and so sort of social, they keep basically every version of a file that ever gets created. And they're in that independent place, and they'll sort of transparently resolve conflicts by just having the most recent one win. But the important part is not that. I mean, that's a key thing. But the important part of their conflict resolution is that you get a little notification in the app, and then you go to the website and you can download every version that ever existed, and it's your responsibility to, like, merge them or pick them out or whatever, and you have a separate file system that happens in.
Yeah,
and
there's
so,
never any
like,
danger of losing data, basically.
Yeah.
The conflict never loses data, yeah. So, I mean, we could, if we had an idea
like,
of keeping...
we would need to have everything would need to be log-based, or, like, you know, yeah, it would need to be like a log-based file system or something for us to have any hope of making that work, I think.
I think the first step might... I see Sage's optimistic approach. The simplest way to have this at first might be to detect a conflict and refuse to merge. And, you know, if you do that, let the user sort it out. That would probably be the best first step with this very complicated path.
Yeah, I think that in order for it to be feasible, though, you'd have to choose something so that if you didn't touch it, it wouldn't, like, be broken, right? It's making it able to safely roll back. So I think Greg is right. Having those file revisions is like the key thing that would make it.
Yeah, and I mean, that's the thing you can build on top of Ceph or Rados, and I think people have even done that in the past, but I don't think it's something we want to build inside of ourselves. Like, maybe someday we have another top-level project, but...
Well, actually, we do have that. You know, if you detect a conflict, create a snapshot, you know.
But then you have, like, frantic snapshots across the version or across the site.
Yeah, I think the trick is that they would be divergent, right? So you'd have version A on both sides the same, and then you'd have, like, B and C that are different, and then you try to sync, and then ideally you would have both versions on both sides, but they would also have the same winner, but the ordering is wrong because you'd have BC and you'd have CG. I don't know, it's weird. So, but if we did come up with a way to, like, keep sort of a third dimension, nth dimension, where you have revisions of a file, sort of at the Cephifus level, I think that. So there are two reasons why I like it. One, it would enable this bidirectional sync with versions, so that the user has an option to go revert, and we can invent some, like, dot version directory to manipulate those or whatever we want. The other reason why I like it is this idea that I got from hearing Dan talk about their Nextcloud backend that backs into their big EROFS, whatever it is, at CERN, where they have sort of a POSIX-like interface to a huge file system, and that same file system is exposed to Nextcloud on the front end. And so you can, like, check out bits of the huge data set, like on your laptop or your desktop, and check them back in. And so you sort of, and it usually when you have a backend for something like that, it's like just storing blobs with all the versions of files, and so it's opaque. But having sort of the POSIX backdoor, so that you can access it via the POSIX API or via the Nextcloud thing, where you get all the same file revisions, it seems pretty powerful to me. But it means that you have to, like, push this version management into the file system itself, which is a...
Well, yeah, and I mean, and they're already running NextHub, right? So that's the app that runs and does the conflict detection and resolution for the user. and what they put in us is like the resolved ones or whatever, and they can still expose our Ceph snapshots to the users, different versions. But
it means that you only get those features viewed through Nextcloud. Whereas if you push them into the file system, then you can leverage that same capability to do active-active across geographically distributed sites, which is cool. And also you can have like a regular POSIX file system that like your legacy stuff is accessing, and also access those same data sets via Nextcloud and have all the same.
I mean,
so it's you're piling all the features on top of each other, but the combination is pretty cool.
I mean when we've talked about adjacent things to this in the past, it's been like, we could have a log structured file mode, or we could have snapshots be different objects instead of radar snapshots, and those all make building in these sorts of features a lot easier and more practical. But I don't really see it with the existing file system layout, just because it's a whole lot of layers that are built in the wrong direction. Plus, if we put this in there, what we're assuming is that all of the clients, which means all the guys on their laptops, are like running a Ceph mount, and we're not set up for that either.
Well, they don't have to be. Like the laptops could use Nextcloud, right, and just synchronize it.
Well, yeah, but then in Nextcloud is the right layer for this. So.
Yep. All right. Well, that's my crazy idea.
Just one question regarding the snapshot. So, and maybe just inserting that, I like having it in CephFS Next. One comment that we hear and that some users aren't aware of, because, well, we can do snapshots with RBD, with RGW, and with CephFS, right? That would be cool. Is that they then end up running a workload that accesses them at different points. So at some point, we need to take a consistent snapshot of, all the layers, not just the Manila file system, but the Manila file system at the same point as the workload VMs. That will be tough in the future somewhere.
Yeah, those things are all pretty separate.
And I think you would need to coalesce stuff inside the VM for that to work anyway. And at that point, is there anything we need to do besides say, yes, we've made the snapshot for you?
No, wait. So the thing is, we do, the snapshots are the VMs are backed by RBD. Right? They have snapshots. They can be mirrored. They can be replicated. And then the files, and that's atomic. Essentially, they are consistent. But then the file system that they are accessing and working with comes along and is consistent at a different point in time.
So, but I mean, that's going to be true even if we had a unified snapshot mechanism, because you don't know what your applications have actually put into the file system versus in their like RBD journal device.
Or their page cache or whatever.
You need the VM to actually coalesce I/O and flush everything. And once you have the VM coalescing I/O and flushing everything, then it can just wait for a little utility that goes and takes a separate snapshot, but while all I/O is coalesced inside of all those mechanisms.
Right. It would take 2 snapshots instead of 1.
But they would be with coalesced I/O, so they're the same and they're unified and consistent across each other. Yeah. Is there any way you can do that without having an agent that does the I/O coalescing inside the VM, Lars?
Well, in theory, properly written application uses fsync and fdatasync, all those things, and is consistent on disk. That's what a database, a properly written application would do. They're crash consistent.
So that's I think that's what Greg's saying. Your application would fsync and then say, okay, now I'm ready to take the snapshot. And then it would take a snapshot of the block device and the file system. And then it would continue.
No, you don't have to do anything special to the application. Any application that's not always crash consistent would essentially lose data when the server crashes. So outside the Redis world, most people frown upon that.
I see what you mean.
Oh, you're not worried about cross-application. It's a single application using both mount points.
Yeah. Yeah, that would have to be serialized in the kernel, I think, that the application is running on. I don't know. Kill dash stop the process. Take your snapshots. Kill dash continue. That's your problem.
I mean, is that something that could be feasible in the kernel? Like, let's leave out fuse for the moment and just pretend they're all like kernel mount.
And you'd have to have like a global walk or something.
Well, the trick would probably be to
schema mounted anyway, not RVD kernel mounted. Yeah.
You would freeze them at the hypervisor level. You would freeze all VMs, take your snapshots, and all layers.
Yeah.
You forget the caching, so you have to actually have an agent in the VM.
Yeah.
No, you do not.
Well,
honestly,
no, the application needs to be issuing the actually go to disk command as well.
Yeah.
Yes,
which we respect in our caches.
Yeah.
Yeah.
You can freeze the VM and it'll be crash consistent. Or it'll look like a crash. Yeah. All right. We're over time. Do we want to talk about the RGW stuff now, or should we punt it to next time?
We can punt it to next time. It's been
okay.
very, very long.
Well, actually, prefer to, because next time it's 3 a.m. for me, so I won't be it.
Okay.
Okay. So I think that I'll give the really high level message here is that can and should we be changing our perspective and our thinking around RGW as a S3 compatible gateway for a Rados cluster that happens to have multi-site capabilities to instead be a gateway to a whole topology of storages, whether they're Ceph clusters or public cloud storages or whatever, where the gateway knows how to access your data and it gives you an S3 interface, but behind it, maybe it's storing your objects in Ceph, maybe it's replicating into multiple sites, maybe your objects are all over the place and it knows how to find them, maybe they're being encrypted and then stored in the public cloud, maybe it's a combination, maybe it's stored in one cloud and it's in the process of being migrated to the other. But if we think about RGW as sort of a gateway that's just mediating access to this whole federated topology of places where your objects could be stored, then that sort of gives rise to this whole set of data service-like capabilities where we can add in smarts to manage where your data is stored and replicate it and give you cloud portability and all kinds of good stuff. Anyway, that's the high level. And what that actually translates into is a whole bunch of features and abilities in RGW that are outlined in this document. Do you want to? Yeah.
Pretty much. Like I think there are two main paths that we'll need to take. One is finishing the whole cloud sync feature. Like currently, what we have in Mimic is sync to cloud, and we want to have sync from cloud capability also. So that will give us the ability to look at a cloud as an entity that we can fully sync to and from, and and provides the whole data mobility functionality. And the second thing is which is not necessarily related to that, but the second thing is the ability to have RGW tiers on the cloud, which means that objects could be either on Rados or either on the cloud provider in the back. And these are two separate issues, whether you have a whole zone that is backed by the cloud or a zone that is kind of hybrid where data can stay in one, one policy that says it's going to be in Rados, and another policy that says it's going to be, in that cloud provider. A third policy is going to say something else. And one more thing is currently we look at the data at the zone level. We say everything in this zone is going to be replicated to another zone, all within the same zone group. Very DR. It's a DR feature basically. So as a zone backs up another zone. But when dealing with data mobility and the ability to move data around and to be, modular, we might not want to look at the zone as the unit of that we think by, but maybe look at the bucket itself that would allow us for better flexibility on one hand, and it doesn't constrain us. And no one necessarily wants their entire zone back to S3. Maybe not no one, but it has implications. But it's a subset of the data, definitely. So that's where we are. As it currently is, it looks to me that the next step would be to do sync from cloud. That would be like the next big step. Now there is tiering that we'd be happy if someone took on them. One more thing to note is when looking at the gateway for external data, there are multiple options on how to do it. One is the gateway can be a proxy for the external data. Another option is the gateway just redirects and says, this object resides in this endpoint. That's URI. Maybe it's going to be a pre-authorized, how do you call it? Pre-authenticated URL that we redirect to, so that users will be able to get it directly from where it is at that point. So these are main two options. And then there's a question: do we do it only for read operations, or do we also do it for read and for puts? Yeah. But then it really depends on where we are exactly in the stack.
The puts sound much harder, because if we're talking about in the tiering case, you have to have the metadata about individual objects still stored, managed by RGW, and so you have to record the metadata and also.
Not necessarily, depending. The objects themselves can be just soft link, right? It can be their manifest can say, okay, the data is somewhere else, and everything, including metadata. But if RGW doesn't know what the metadata is, then when listing the buckets, you're not gonna have all the information. And right. So.
Yep. Okay. So there's the, as far as possible next steps, there's the tiering piece where an individual object would be a redirect. It's actually stored in this external object provider, cloud provider, whatever, which I guess optionally would have encryption. Would be cool. So it would be opaque on the other end. Then there's the zone or bucket granularity replication. I guess, did you mention that? That's one thing. Sort of different dimension, different direction. What was the other one you mentioned? Cloud sync. Cloud sync
from cloud.
Yeah. Okay.
Right. Now, the one thing about sync to cloud and sync from cloud. These are the way things work right now. When you sync, when a zone syncs, it always pulls data. So if you want to have sync to cloud and sync from cloud, right now the way it works, you'll need to have two different separate zones, right? One for the where you want the data that you sync from the cloud is, and one and a zone to sync the data into the cloud. It might be maybe a second iteration we can think of how to consolidate it, because at the end you're representing a single cloud, and you don't want to start zones. Too many zones.
Right. It feels like there's a set of. I didn't get a chance to read this whole document here, but I think you probably covered a lot of it. But yeah, identifying what the specific capabilities are, like at the bucket layer, mapping that says this entire bucket is stored over here, or at the per object basis saying this object is stored over here. Yeah, and then we can talk about how we'd implement sort of the key capabilities, like migrating a bucket from cloud A to cloud B in a seamless way so that access is uninterrupted based on those pieces. Yeah, okay. Go ahead.
When a bucket is on the cloud or at the remote endpoint, it's not a one-to-one mapping necessarily, because the clouds have their own limitations. So you might have multiple RGW buckets residing in a single cloud provider bucket, and there's some naming mutation that's happening, and there's ACL mutations that are happening. That's how it works now with the Mimic cloud sync. So there needs to be, when you do sync from cloud, we need to do a similar back mutation or some other solution that make it possible.
Yep, that makes sense.
Yuda, I have a question about user. Do the user need to have the same, like Redis gateway user and S3 cloud provider user? The same key secret?
And the way the Cloud Sync works now, we have when you configure the sync, you can set a set of ACLs that, like, there are different profiles, and you can have this bucket will use this profile, and another buckets bucket prefix, all buckets that start with some prefix will have a different profile, so it's pretty flexible. And then there was a way to also define how you map users in RGW to users in the backing cloud. Also, moreover, you don't even need to run a single cloud, and you can, in theory, you have some buckets go to S3, some buckets go to Azure. Not that we support Azure at this point, but or maybe to different S3 region at this point, so that it's pretty flexible. You can mix and match.
Cool.
But for that, don't you need to create like one zone for each cloud provider or something like that, like one for Azure and one for S3 or something like that?
Not really. Not really. Currently, there's no need for it. You have a logical unit that defines how you take the zone and pushes it to the cloud. But in that logical unit, some of the buckets can go to one provider and others can go to another provider, in theory, because it's only in theory, because currently we only support S3. But yeah.
Okay. That's all I have. Sounds good. You guys are meeting in July, right? No, in August. I can't remember.
You guys is
The RGW team is
like
getting together. I guess
like
August.
late August, yeah.
Late August. Okay. All right. I imagine this will come up then, if not sooner. I guess my general thinking is that the more we can sort of map out the roadmap for these different features, the more we can get other folks interested, like our friends at Cloud who've been writing so much code recently, or whoever else. Because it'd be nice to get the tiering stuff rolling.
Yeah, I agree. We've been discussing tiering, and not necessarily even to the cloud, just tiering in general.
Tiering in general, yeah.
For many years now, and it always like was the next thing, on our roadmap.
Yeah, exactly. Yep. Cool. All right. Anything else? Okie doke. Thanks, everyone.